Hello everyone, myself P. Mounika from the Department of Physics and Electronics, K.B.N College, Vijayawada. Today I am going to tell Unit 5 of first BSc Physics, that is nothing but ultrasonics, which will be there in the slide. In this presentation I am going to cover the following topics. Those are nothing but introduction to ultrasonics, properties of ultrasonic waves, ultrasonic production by using some methods like Magnetostriction Method and Piezoelectric Method, and applications of ultrasonics. These applications includes applications in various fields like medicine, research, etc. So these are the topics which I have to cover in this presentation. So firstly we will go with the definition of ultrasonic. What does that it means? So the word ultrasonic combines the lattice words, that is nothing but ultra, first word, ultra is nothing but beyond, and sonic or source. So ultrasonic came from the Latin words ultra and sonic. So these sound waves having frequencies above the audible range, that is above 20,000 Hz, are called ultrasonics, which we can't. Okay. Generally these waves are also called as high frequency waves. The field of ultrasonics have applications for imaging, detection and navigation. The broad sectors of society that regularly apply ultrasonic technology, and these will be useful in medical fields also. So these are the features. They have a high energy content, just like ordinary sound waves. Ultrasonics get reflected, refracted and absorbed. They can be transmitted over large ranges with no appreciable loss of energy. They can travel for more large distances without loss of any energy. Okay. If an arrangement is made to form stationary waves of ultrasonic in a liquid, it serves as a diffraction grating. So it is also works as a grating when we arrange it in a stationary waves. They produce intense heating effect when passed through a substance. When it is passed through a substance, it will produce an intense heating effect. These are the features of ultrasonic waves. So ultrasonics production. So we can produce ultrasonic waves by using the following methods. Those are nothing but magnetostriction generator or oscillator, and the second method is piezoelectric method. That is nothing but piezoelectric generator or oscillator. So here you can see by using these methods we can produce ultrasonic waves. So first one is the magnetostriction method. So the principle of this magnetostriction method is nothing but when a ferromagnetic material like rod or iron or nickel is placed in a magnetic field parallel to its length, the rod experiences a small change in its length. This is called magnetostriction method. Here you can see, you can take the material like iron or nickel. When you place that material in a magnetic field, it experiences a change in length. That is nothing but a magnetostriction method. The change in length, why this change? The change in length, whether increase or decrease produced in the rods, depends upon the strength of the magnetic field. So the variation of length is not fixed for every element. It depends upon the strength of the magnetic field. The iron, the change in length of iron is different, and the change in length of copper is different. So that difference depends upon the effect of magnetic field or the strength of the magnetic field where we kept. So this is the construction, and this is the experimental arrangement of magnetostriction method. Here you can see the transistor, and this is the experimental arrangement of that. So here the alternating magnetic field is generated by using electronic oscillator. In this method, here the coil L1 wound on the right hand portion of the rod along with a variable capacitor C. So here you can see this is nothing but a variable capacitor. This forms the resonant circuit of the collector tuned oscillator. And one more coil L2 wound on the left hand portion of the rod is connected to the base current. Here we have two coils. First coil is nothing but L1, which is on the right hand portion and is connected along with the capacitor C, and we are having the second coil L2 which is in the left hand side portion of the rod, which is connected to the base current. So this coil L2 acts as a feedback loop. When a high tension battery is switched, then the collector current oscillates with the frequency, and that frequency is written as F equal to 1 by 2 pi into square root of L1 into C. We already know C is a capacitor which we joined in with a loop L1. So this alternating current flowing through the coil L1 produces an alternating magnetic field. Here N equal to 1 by 2L into square root of Y by rho. Here L is nothing but the length of the rod, Y is Young module of the rod material, and rho is the density of the rod material. So the capacitor C is adjusted in such a way that the frequency of the oscillator circuit is equal to the natural frequency. So here are the some of the advantages and the disadvantages of this model, that is nothing but the magnetostriction model. So the design of this oscillator is very simple, so the cost production is very low. This is one of the advantages of that method, and at low ultrasonic frequencies output can be produced without the risk of damage of any oscillatory circuit. So at low frequencies also there is no damage for the circuit, so this is one more advantage of that magnetostriction method. Coming to the disadvantages of that method, it has a low upper frequency limit and cannot generate ultrasonic frequency above 3000 kilohertz. So this won't produce the ultrasonic waves which is of frequency range above 3000 kilohertz. This is one of the drawback of that particular magnetostriction method, and the frequency of oscillation depends upon the temperature. So by depending upon the temperature, the frequency of oscillation depends. So principle, so this is nothing but one more method of producing ultrasonics, that is nothing but an inverse piezoelectric method. So in this method you can see, if mechanical pressure is applied to one of the opposite faces of the crystals like quartz, equal and opposite electric charges appear across its other faces. This is called piezoelectric effect. So when we apply a mechanical pressure or force like to a crystal of opposite, the charges are produced. So this is nothing but piezoelectric method. Here you can see in the diagram, the converse of piezoelectric effect is also true. So this is the circuit diagram which we can see for a piezoelectric oscillator. Here also one transistor and two coils L1 and L2, and the L1 is connected along with the capacitor C1. So the plates are connected to the primary coil, that is L1 which is coupled electronic oscillator. So the electronic oscillator circuit is a base tuned oscillator circuit. Here we are having two coils L1 and L2. The coil L1 and L2 of the oscillator circuit are taken from the secondary of the transformer T, and next the collector coil L2 is inductively coupled to the base coil L1. So this is nothing but the description of that particular piezoelectric method. When a high tension battery is switched on, history is nothing but high tension battery is switched on, the oscillator produces the frequency. That frequency is given as we already seen in the magnetostriction method also. The frequency is same, F equal to 1 by 2 pi into square root of L1 and C1. So due to the transformer action, an oscillatory EMF is induced in the coil. So inverse piezoelectric effect takes place and the crystal contracts and expands alternatively. So here the crystal contracts and it expands. So the frequency of that vibration is given by N equal to P by 2L into square root of Y by P. We already seen in the previous method that Y is nothing but the Young's modulus and P equal to 1, 2, 3, 4, etc. So coming to the advantages and the disadvantages of that particular piezoelectric method, here the advantage of this piezoelectric method is nothing but the output of this oscillator is very high. It is not affected by any temperature and humidity. Here you can see in the third point, it is not affected by the temperature and humidity, but in a magnetostriction method that method is depends upon a temperature. So this is one of the main point which is difference between these two. So these are the some of the disadvantages of this piezoelectric method. The cost of piezoelectric quartz is very high, so that this comes as one of the disadvantages of it. We can't the cutting and shaping of quartz crystal are very complex. So these are the applications, nothing but piezoelectric detector method. So ultrasonics are used for making holes in this is nothing but, these are all the applications of ultrasonics. Yes, The properties of some metals change heating, and therefore such metals cannot welded by electric or gas welding. So these are all the applications comes under ultrasonic waves. So it is having so many applications like ultrasonic soldering, ultrasonic welding, ultrasonic cutting and machinery, and ultrasonic cleaning. So here you can see in the 6th point, ultrasonic cleaning. This is one of the main application which are widely using in this society. It is the most cheap technique employed for cleaning various parts of the machine, electronic assemblies, armatures, watches, etc., which cannot be easily cleaned by other methods. So cleaning the watches or assemblies like so small machineries, it is not possible to clean in another methods, but by using ultrasonic cleaning we can clean all these with a simple technique. It is also a most cheap technique also. So one more application, that is nothing but sonar. So sonar stands for solar navigation and ranging. So it is a technique, it uses ultrasonics for the detection and identification of underwater objects. So we cannot detect the objects underwater with our naked eye, but by using these ultrasonic we can this will be useful for the detection and identification of underwater objects. The method consists of sending so this method includes sending a powerful beam of ultrasonics in the suspected direction in the water where we have to find that object. By noting the time interval between the emission and receipt of beam after reflection, the distance of the object can be easily calculated. So the change in the frequency of the echo signal due to the Doppler effect helps to determine the velocity of the body and its direction. So in this method we can find the object which are there under the water by using ultrasonics. So this is nothing but a sonar. This is one more advantage. So here we can see the applications of sonar. So sonar is used in the location of shipwrecks and submarines on the bottom of the sea. So we already know submarines is in under the sea. So these sonars will be helpful for the submarines which are on the bottoms of the sea. It is useful for fish finding application. It is useful in survey also. So mainly the sonar is used to find the object which are underwater by measuring the velocity and the direction of that object. So ultrasonics are having the applications in the medical field also, that is nothing but diagnostic sonography. So it will see by using the ultrasonics we can say the date of the pregnancy, check the location of the placenta, checking for the number of fetuses, how many babies are developing in the uterus of that pregnant lady, and checking for a physical abnormalities and checking the sex of the baby. So these ultrasonics are playing a major role in the medical field, like it will detect all sex, like physical abnormalities, number of fetuses, placenta, etc. in a medical field. So these are all the applications of ultrasonics. We already saw the applications in industries, and we already saw the applications in the medical field, and one more application is nothing but in a research also. Scientists often use in research for high molecular weight polymers like new plastic materials. Indeed, ultrasonic also makes it possible to determine the molecular weight of a liquid polymers also, and to conduct other forms of investigation on the physical properties of matters. So one more thing, ultrasonics can also speed up certain chemical reactions, hence it has gained application in agriculture also. So this is about in this presentation we gone through the introduction of ultrasonics and the methods of producing the ultrasonic waves and the applications of ultrasonics in various fields like industries, medical, and also in research. Thank you.